We have joined here for the webinar on experimental techniques and related analysis method in nanomaterials. It's an immense pleasure to have Dr. Keval Gadani as our today's expert. A warm welcome to you, sir. I would
Thank
like
you.
to take this opportunity. Welcome, sir. I would like to take an opportunity to introduce the expert. Dr. Keval Gadani, sir, is currently working as an assistant professor in physics at Indian Institute of Teacher Education, IIT, Gandhinagar. He has completed his MSc and MPhil in physics from Saurashtra University, Rajkot. He obtained his PhD degree in June 2018 from Department of Physics, Saurashtra University. During PhD, he worked on swift heavy ions, irradiation studies on magnetite-based thin films and devices at Inter-University Accelerator Center, New Delhi. He's working on functional oxide materials such as mixed valent magnites, multiferroics, diluted magnetic semiconductors, and metal oxides. He has proficiency to deal with the research on some special techniques such as swift heavy ion irradiation, low energy ion implantation, and temperature magnetic field dependent neutron diffraction. He has been awarded for Best Research Paper Presentation Awards for 2 events at international level and for 1 event at national level. He has published 42 international research articles in reputed journals and 13 international proceedings through various events. Dr. Grani sir has more than 7 years research experience and more than 3-year teaching experience at UG and PG level. He has strong research collaboration with SFAX University, UGC Day CSR Indore, UGC Day CSR Mumbai, IUAC New Delhi, IPR Gandhinagar, Central University of Rajasthan Ajmer, and UGC Day CSR Kalpakkam. I welcome you, sir, for this expert talk and webinar. Please, sir.
Thank you so much. I hope I am perfectly audible.
Yes, sir, you are audible.
Okay, thank you. So first of all, I would like to thank to organizer team, Parul Institute of Engineering and Technology and Parul Institute of Technology, Department of Applied Science to give such a good opportunity to share my experience and research regarding especially in nanotechnology. So plan of my today presentation. Introduction to nanotechnology. I will talk about first of all nanotechnology, then nanotechnology for research, and especially the main topic experimental techniques and related analysis method, and last but not least talk to nanomaterial for better future. So we start with the nanotechnology, but before I am going to start the nanotechnology, we all are know, dear friends, we all are know about the state of matter, solid, liquid, and gaseous. So just want to, once we have to clarify, means to define the solid materials. So in the periodic arrangement of atoms, okay, and the classification of solid material, crystalline material and non-crystalline material and amorphous. So now here you can see this is the periodic arrangement of atoms. So we can easily define the solid material. And between two atoms, some bonds are there. Now in the case of liquid, the atoms and molecules, they are not strongly bonded to each other, but we can see represent the atoms in the liquid state. Similarly, in the case of gas, the free molecules and atoms, they are means in the gas state, they are free to each other. So they are easily moving to like this. But in the case of nano, so we can define, we can represent this kind of the unique and beautiful pictures. And now here you can see here, this is the very small groups, the bunch of atoms and molecules, and between the two groups have some boundary, okay, some gap. So in nanotechnology, once if you want, if anyone who want to define the nanomaterials, so it means nanomaterials is the combination of grain and grain boundaries. So grains are there and boundaries are there, okay. So it is the very this is the very beautiful schematic diagram, so we can define the nano. Now we start with the our main journey, nano. So from, you can see here, from right to left, it is the all about the dimension, all about the dimension. So once we start the journey from centimeter to 10 centimeter to 1 centimeter, in order of centimeter to mm, then micrometer, okay, micrometer, 10 micrometer to 5 micrometer, and then 1 micrometer up to, and then we shifted in the nanomaterials. In the case of nanomaterials, so it's the 5 nanometer, 10 nanometer to 5 nanometer, and then zero point 0.5 nanometer to zero point 0.1 nanometer. So it is a very beautiful journey in the order of range, the dimension, okay. Now further, if one means how big nano, मीन्स एक साइड हम बात कर रहे डायमेंशन की. सो हाउ बिग नैनो. सो हियर यू कैन सी हियर, इफ यू टेक द रेशियो अर्थ एंड फुटबॉल, and other side, if you take the ratio of football by fullerins, the answer almost equal, answer almost same. So it is a very beautiful or very big nano. Now if we take the some good example in our day-to-day life regarding the nanotechnology. So a human fingernail grows 1 nanometer every second, 1 nanometer every second, and a main beard grows 5 meters every second. So this is the example of nanotechnology or nanometer, nanotechnology. Now in further, we always like this peacock feathers, and very beautiful. Why it's very beautiful? Behind the nanotechnology, it means nano responsible for the different colors of peacock feathers, okay. One more example, this is the due to the nanotechnology. And now one more example, we every time we see the butterflies, so the beautiful pictures, and due to the different colors, okay. So the nano responsible for the different colors of the these butterflies, okay. So now this is the day-to-day life we are observing the such kind of in our natural environment. And the nanotechnology, it means nano is there, the presence of nano. Now one more example, if we take the suppose the silver nanowire and resting on a human hair, and now look at, means your own hair, and imaging how the small that is. You can see the beauty. This is the picture, you can see the your hair and the silver nanowire. So this is the what about it's tell us the dimension of nanomaterials. So it is the very small nanomaterials. So now this is the definition of nanotechnology. So nanotechnology involves the designing, fabrication, production, and last application of nanostructures, device and systems, and the size in order of 1 to 100 nanometer. We all are know, because in this platform the few of MSc students and research scholar is there, okay. So and the few students from the outside, they from the science background, and most of them know about the nanotechnology, and they can define the nanotechnology. The range in order of range is 1 to 100 nanometers. And if you I will not about the here the discuss about the synthesis, but once if you want to synthesize the nanomaterials, okay, so we have a two option. One is, means we have two approaches, one is top down and another is bottom up. So if you see in top down approach, from bulk to nano, from bulk to nano, it means from the top to down, okay. So we have some good synthesis method, okay, and then starting from the bulk, and then we go for the nanomaterials. So it's called the top down approaches. Similarly, from the bottom up, means we start from the atoms and molecules, and then again we go for the cluster, and then finally we get the some good nanomaterials. So but in this presentation, it means at present I will not talk about the further discussion about the top down method and bottom up method, but in later on definitely in one paper is there, nanotechnology, and then you definitely you can see, and then you further, if you use the some good reference book, and then you will get the some good information regarding the top down approaches and bottom up approaches. Now the further moving ahead, the why the nano is very important, because in the if you look at the properties of nanomaterials, so mechanical properties, electrical properties, these are the list of properties, optical properties, high surface energy, and nano range size. This is the very unique properties of nanomaterials, and is the property of nanomaterial is very different from the bulk. So that this is the importance of nano, because at the nanoscale the strange things happen to material there, the properties can change. Because if you compare from the bulk and nano, and then definitely you will get the some new property in the when you reduce the size of the same element. The first of all is the reactivity. First of all, the reactivity. So as the particle get the smaller, then tend to react the differently with their environment than larger particles. Okay, so it is the matter of size. The smaller particles can have a different optical properties. And once, dear students, once we are talking about the optical properties, and then optical properties is directly related to the reflection and absorption. Okay, so it means as a result, we can conclude that the different size of the particle react and absorb light differently. Okay, because it's the matter of size. Okay, and then last but not least, the magnetism, means smaller particle can have a different magnetic property, okay, than larger. So it is a comparison point of view, the bulk and nano. But why the different property? What is the main reason why the nano is very important? So we can easily understand with the help of this example, because this is the very unique example to learn the nanotechnology, means importance of nano. Because if you take the two glass and fill with the water, and I want to dissolve sugar in this in water, and in the one case I use the granule sugar, and the second case I use the sugar cube, and then you can and then stir, and then which get the faster dissolve. Okay, and then we know the granule sugar can easily, means can fast dissolve as compared to sugar cube. So it's the high surface volume ratio, increase the high surface volume ratio. So it is the reactivity. Okay, surface area large, it means reactivity more. Okay, the nanomaterials can easily react. Okay, the faster reaction. Okay, so now this is the best example to learn the nanomaterial. It means importance of nanotechnology. Okay, last but not least, अभी हमने साइज की बात की. So my dear students, now here I'm not talking about the gold, okay, because you know the price of gold is very large nowadays, but we are talking about the gold nanoparticles. So now here you can see the color of gold can range from the purple to red, and depending on the size of the atom cluster. So the element is okay. Now you can see this is the liquid. It means the gold nanoparticles, and this gold nanoparticle have a different color. Why the different color? Because the size, because of size. Okay, so optical property can easily, because different particle have a different absorb and reflection property. So we can see that this is the different color of gold nanoparticle. Now now this is the very important part for the research scholar. Okay. In this platform, I think many of students who are doing the research in nanotechnology, number one, and those students, okay, listening to me in through this platform, and they want to do the research, okay, especially in the nanotechnology. So now this now upcoming discussion, my discussion is very important, because in research, in the field of research, okay, how can I do the best analysis, okay, how can I do the best analysis? So now means at present I will talk about the structure property and microstructure structure property, because these two properties very important in the field of research. So my next topic, it means the experimental techniques. So experimental techniques में structure property and microstructure property, both the properties are very important role. Okay, so now in the classification of nanomaterials, start with the 0 dimension, 1 dimension, 2 dimension, and 3 dimension. Okay, so I will talk about the thin film, because my research area, okay, I had my particular research area in thin film. Okay, so we can consider thin film as a nanomaterials, as a device. Okay, and we can put the thin film in two-dimensional nanomaterials. So generally, ideally, we can see the nano thin film. We have required some substrate. Okay, and we can grow the. I'm not talking about the synthesis of thin film at present. Okay, but now here from this my slide, you can see the device. Okay, the film layer. Okay, आपको जिस मटेरियल की फिल्म बनानी है, we can grow the film, okay, by using the some chemicals, and okay, and then we grow the film thin layer, okay, thin layer on the particular substrate, okay, on the particular substrate. And once successfully grown the thin film, and then definitely we go for the some characterization techniques, because now this is the very important. Okay, the many of the research students are there, so and they know about the what importance of characterization. So the XRD measurement, 5 scan measurement for particular thin film, and the AFM measurement, it means the atomic force microscopy. So structural and microstructure properties are very important. And if you want to do the best research, so you must be know about the some good software. Okay, so this software is very useful to learn and to do the research easily. Okay, so that the software will help for data analysis purpose. So now let's see the some one slide, the data analysis. So now here we start with the origin, and the name of software and the link I have put here. I already put here, so you can get the access. Okay, and it is the very free of cost for the research student. You once you download and you do the self registration, and then you can use the software. So origin is there. Okay, you can note down. Okay, अगर आपको note down करना है, then you can note down here. Origin is there, image J software, powder X software, okay, and the nanoscope software, and last but not least WS cross M software. So now the origin is very unique software. Okay, for if you want to plot the graph and everything, so we go for the origin. Now the powder X software, this powder X software is very useful for the XRD purpose. Okay, image J software used for the TEM, and nanoscope and WS cross M software used for the AFM. Okay, atomic force microscope. Okay, once you have a AFM image, then we further, if you want to do the analysis, okay, then with the help of software you can do the some, you can calculate the grain and grain size and surface roughness, everything. Now further moving. Okay, now you become a, once you started the research, then become a good observer, because as per my knowledge, okay, as per my experience, I can say that a good observer learn many things as compared to a good learner. Okay, so in research you have to become a very good observer. means observer, it means आपको क्या observe करना है. You can observe the some good research paper once you search, and then you can see the some graphs and some plots, and then in the inside the graph what happened, what it tell us, because each and every graph something tell us. So now the next couple of two slide, we can take the some example, some reported research work, and then we start the some observation. Okay, so this way we are going here. So now we take the one paper. This paper is already published in Applied Physics A, and now in this paper, if you search, if you see the one graph, and this graph of thin film XRD graph, it's called the XRD measurement, and one more graph is there, and this graph is the name of this graph is called the phi scan measurement. So now you can see the such kind of the graph in once you further, it means once you look the any research paper, so particular in the material science, particular in nanotechnology, so once you frequently observe the XRD measurement, okay, I'm talking about the only particular thin film, so phi scan measurement. Okay, so one more reported paper. So now here you observe the XRD measurement graph, and now the so many number of film peak are there. So this peak means film possess the polycrystalline growth. Now here in this previous class you observe the only one peak. Okay, only one peak. Okay, film main peak. Okay, and now here you observe the many number of film peak. Okay, so from the number of peak, okay, we can get the idea. Okay, so polycrystalline है, single crystalline है, okay, वो हमें पता चल जाता है. Now the further now here in this paper solid state communication, now in this paper you can observe the one single main peak. Okay, film की बात मैं कर रहा हूँ. So now this is the single crystalline growth. It's called it means the film itself possesses the single crystalline growth. Okay? So the good observation is very important in research. So how you can get the idea? हमें कैसे पता है? Means how you can do the research in thin film. Okay, so experimental techniques, it is the part of experimental techniques. So suppose if we take the example, suppose this is the SRTiO3, this is the substrate. Okay, and now here you can see the one film NIO. This is the film of material film, and now the SRTiO3 STO, it's called the STO. This is the substrate peak. And now another, you can see the second graph, STO substrate, and the film peak is there. Two film peak is there in the second graph. You can observe one is BFO and one more is BTO. Okay, BiFO3 and BATiO3 BTO. Okay, but now you observe, dear student, now you observe only the STO. So if STO is substrate, so in the both the graph STO is common. In both the graph STO is common. So the STO have one unique, it means fixed peak. Now you can see the first peak of STO. This is the around the 23 degree, and the second peak of STO and around the 46.5 degree. It means that once you select the STO or once you select the any substrate material, so each and every substrate material have a unique peak. Number one. Number two, now the second observation, now you see the film peak. Okay, so we have a two possibility. Either film peak left side of the peak of substrate or right side of the peak of substrate. Okay, कि film की peak है या substrate के पास ही होगी, right side or left side. Okay, it depends on the nature of your material. So now this is the common things I think you should know regarding the XRD measurement, particularly in thin film. So now analysis, if you see the analysis part of X-ray measurement, so first of all, you have to confirm the substrate peak. As earlier I told you, number one, Second, observe the film peak. Okay, first you confirm the substrate peak, and second, observe the film peak. Now the third one is any separation. Did you find the any separation? Separation between the substrate and film. Okay, because you observe the two peak. One is substrate peak, another is film peak. So did you find the any separation? This is your third question. Now the lattice mismatch. Okay, once you find the any separation, it means the mismatch. It means definitely have some lattice mismatch. And after lattice mismatch, then the next step is to calculate the strain value. Okay, we have one formula to calculate the strain value. Okay? And on basis of formula, we can calculate the strain value. So we have two possibility, either positive or negative. ओके हमें जो वैल्यू मिलेगी वो पॉजिटिव भी मिलेगी और नेगेटिव भी मिल सकती है. ओके, सो नाउ टेक द वन एग्जांपल. सो नाउ इन दिस एग्जांपल यू कैन ऑब्जर्व द ग्राफ. ओके, आप सबको ग्राफ दिखाई देगा. So the first graph is the substrate graph, SNTO. This is the graph of substrate. And the second graph, one RMNO3, okay, manganite layer film already grow on this SNTO substrate. And now the first of all, we all are confirmed the substrate peak. Okay, I hope you all are agree with me. Number one. Number two, now we observe the film peak. Yes, crystal clear, we can see the film layer. It means film peak. Okay, third one is separation. Yes, we observe the separation between the substrate peak and film peak. So definitely the presence of lattice mismatch. Okay, so we have calculated the strain value. So now here you can see the we have one formula. D is equal to D substrate minus D film by D substrate into 100. It means 100. It means in order of percentage. Chalo. So what is the D? D, it means D spacing. Okay. So how we can calculate the D spacing? How we can calculate D spacing? So now we go for the software. It means with the help of software. With the help of software, and the name of software is PowderX. The name of software is PowderX software. So once you know the value of D of substrate and film, and then we put the value, and then we can easily calculate the strain value. Okay, so now the positive and negative, we have two options. So it means tensile strain is there and compressive strain is there. Okay, it depends on a value. It depends on a value. So now earlier I told you the PowderX software. So with the help of PowderX software, now we can get this two peak. One is the substrate peak, and another one more is the film peak. So now on the right side at the top, you can observe the 2 theta and D. D is the earlier I told you. So now here you can see the two value. One is the D substrate. You can see in my slide, and D film. Okay, so we put this value in our equation. Okay,